All right, I couldn't get this lesson to record when I did it on Zoom earlier, so I thought I would do a quick video on the roller coaster crew project. This is 8.07. So part A, we're creating you're choosing a third degree polynomial for the first part of your roller coaster. And the first question, the two kids are talking, and one of them says that a third degree polynomial can have 4 intercepts. And the other one says, no, it can only have 3 zeros. Can it have 4 intercepts and 3 zeros? We're going to come back to this after we graph it and see what it actually looks like. It says for question 2, you're going to pick one of the functions that they gave and describe its key features. And that includes our end behavior, our y-intercept, and our zeros. And you might remember me drawing the end behavior like this before. As x approaches negative infinity, what does g of x approach? As x approaches positive infinity, what does g of x approach? So what is our graph doing as we head either to the negative infinity or positive infinity? You'll notice here, this equation, well, you'll notice if I can find the paper that matches it. X cubed plus 3x squared minus 1x minus 3 is not one of the equations they gave here. I'm just doing this so you can see the steps, but you'll have to do these steps with whatever equation you choose. So I went through, I found one that looks really nice on a graph when you're done. So, and it's really easy to work with. The numbers are smaller. So the first thing I'm going to do, you guys remember how to group these so we can break them down and factor them. So I want to group these negatives together and get that negative out of there. All right, so these two, x cubed and 3x squared, have the x squared in common. And that leaves x plus 3 left in the parentheses. And remember, I like to go back and multiply these again and make sure that it equals what it shows here. X squared times x is x to the third. X squared times 3 is 3x squared. So that looks right. Now, like I said, I want to get the negative 1 out of here. And you can see these almost look the same. So once I get that negative out, I have exactly what I want. I have an x plus 3 here and an x plus 3 here. So now I can group these together. X squared minus 1 and x plus 3. Okay, and the reason that you can do that is because I'm still taking x squared and multiplying it by x plus 3. And then I'm going to take negative 1 and I'm going to multiply that by x plus 3. So I'm mathematically doing exactly the same thing that I did here. Okay, so then now when I look at this, I have x plus 3 is really easy to find my 0 for, but x squared minus 1 isn't. But what did you guys just learn that we've done that x squared minus 1 would do? So you did difference of perfect squares, and our coefficient, our a and our c, are both perfect squares. So look, x plus 1 and x minus 1, will that give me x squared minus 1? Yep, because those negative signs are going to cancel out my middle term. So now I have it broken down to 3 factors, and I can make them equal to 0. And x plus 3 equals 0. So means x is negative 1, x is 1, and x is negative 3. So really, you should write them as negative 1, 0, 1, 0, and negative 3, 0. All right, and then I can also put these on my graph here. Here's 1, 0, and here's negative 3, 0. All right. The y-intercept is the next, well, actually it's the easiest thing to find, but I'm going to rewrite the equation down here so you can see. X cubed plus 3x squared minus 1x minus 3. When I'm looking for my x-intercepts, my y is 0. So when I'm looking for my y-intercept, remember my x is going to be 0. So if I plugged in x is 0, this would be 0, this would be 0, this would be 0, and all that would be left is this negative 3, which means this is my y-intercept, negative 3. And I'm going to go ahead and graph that right here. Okay. Now, I still haven't seen what the end behavior looks like exactly. I've got a whole bunch of craziness going on here. It's hitting all kinds of places on the graph. Is it going to come here and then do some squiggles down here? So I found this chart online that's a really easy way to remember end behavior. Oh, and you know what this should actually say? End behavior. Okay, so you can see here are my positive coefficients. Here's my negative coefficients. Here's my even exponents, and here's my odd exponents. So think about what would happen if my x was positive in this equation. So if I had a positive x and I square it, it's positive, and then I'm multiplying it by a positive number, so it's going to go up this direction. Now think about what would happen if it was negative. I have a negative x and I square it. What does that do? It makes it turn positive. And then I'm multiplying it by a positive number, so it stays positive. So when it's a positive coefficient and an even exponent, it's going to do something like that. Okay. If we have a negative coefficient and an even exponent, think about that. If this number's positive and I square it, it's going to stay positive. But then I multiply it by a negative. So this graph is going to flip and go down. Both directions, it doesn't matter, it's going to be negative. Then if I have an odd exponent and a positive coefficient, if my x is positive, it's going to come out positive. But with an odd exponent, if my x is negative, that third time that I multiply the negative, it's going to make it negative again. So these do something weird like that.